You know, when I was your age, we used to come here with my parents and fish here. The water was crystal clear. There was fish, plenty of fish, and tadpoles and even eels. What's the matter, Jordan?
Well, I've been internalising a really complicated situation in my head.
What?
Well, there doesn't seem to be any fish, or eels, or tadpoles. Is it because the water isn't as clear anymore?
That's part of the reason. With pollution getting into the rivers and the streams, many of those creatures have died long ago.
You know, I want to see what this river used to look like. How can we stop the pollution from getting into this water?
Your Uncle Hedley, he works for the council and the wastewater department. He knows all about this stuff. Maybe we should go and ask him, eh?
Okay.
Okay.
Jordan, one of the roles that our council has is to protect the public and the environment from the effects of waste. And at this facility here, we treat the wastewater.
So you guys deal with what goes down the loo, or the sink?
That's right. Every house discharges into a network of pipes and pump stations which run underground under the roads, and that finishes up here, and we have means of being able to take that obnoxious material and make it quite safe.
I learned that fish could die of pollution. Do you guys deal with that too?
That's correct. Come and have a look and we'll show you.
Sweet.
Right, Jordan, this is the first part of the process. We have big rotating drums made of this material, and that takes out all the big pieces of food and the rags. It allows the water to go through into the rest of the treatment process. This is the smelliest part of the whole process. In this process, the water from the millie screens comes in at this point and travels down this channel. On the outside channel you can see it's bubbling, what we call the aerobic zone.
Oh, yeah.
In the aerobic zone, the bacteria use the air that we put in to degrade the polluted material. In this channel here we have anoxic zone. In this zone the bacteria take the oxygen off the chemically bound products that they've made and release the nitrogen to the air. Right, Jordan, what I'll do is I'll show you what happens in the clarifiers. We'll just take a sample out of here.
That looks disgusting.
That is very dirty looking, isn't it? And we'll see what happens to that in a few minutes. And the water from this tank here, which you've seen, and how disgusting it looks, comes up in the middle of this tank here. And then as it travels towards the outside, the solids settle to the bottom, and you can see here the water is quite clear.
So is this water drinkable?
I wouldn't drink it.
So what happens next?
From here it goes through the UV plant, which disinfects the water, and then it goes off to sea. Now this is the UV plant. You can have a look at the lights, but just look at them briefly because they can damage your eyes. This is ultraviolet light, which is very intense.
Are there any chemicals added to this water?
Not at all. This light does the disinfection. In effect, it gives the bacteria a very serious sunburn. And if we look over here, it gives you some idea of the volume of waste that's produced in the city. You can imagine this is going 24 hours a day, and this goes out to sea.
Kora says fish are still dying in our polluted waters. Why is that?
That's a good point. While we treat the water to our utmost ability here, there are some chemicals that get through the system. And things like detergents that you use and your mum uses in the laundry and in the kitchen, your soaps and your toothpastes, we treat it as well as we can, but all of those will still go through. A few years ago, sewage was put into the waterways without being treated at all. And that would use up the oxygen which the fish needed to breathe. And so the fish would die.
So if we can't take out all the chemicals, well, why don't we use less in the first place?
Well, that's a very good point. Knowing what your mother told me yesterday with you and your sister and the detergent, I think we should start there.
Oh, let me help you with that.
No.
Yes.
No.
Yes.
No. Look what you've done!
Spice it.
Spoon?
You know how Coro lives out on the farmlands?
Yeah.
Well, instead of his wastewater coming out to the plant like this, he has a septic tank on his property. It has all kinds of microbes in it that help to break down the solid waste products that leave from his house.
So wastewater from Coro's house is processed on his farm.
That's right. The clean water then runs through underground pipes and into his field. He has to have the tank cleaned out and checked very often to make sure that it is running properly. If poorly maintained, a lot of pollution could seep into the rivers.
I've been thinking about the situation in my head. I'm going to try and find out what chemicals harm our environment. Anyways, thank you, Uncle. Cheers. Laters.
Right, take care, bud. Be kind to your sister.
Hey, Grandpa, what's triclosan?
I don't know.
Is it one of those chemicals that harm our environment?
Maybe you should go down to the and ask one of those boffins down at the laboratories.
You mean like a scientist?
That's the one.
Oh,
You know, you spend hours on that YouTube thing. Why don't you look up some information for yourself?
Okay then.
Okay. Thank you.
Chemicals play mainly two roles for society. The first one is to maintain our health, and the second one is to maintain our quality of life. One thing we have to remember is that once those chemicals are used in the household, they are released into the environment where they can have some effects. Triclosan is one of those chemicals that is commonly used in the household as a broad-spectrum antimicrobial agent to inhibit microbes such as bacteria that can cause disease. This chemical is found in a wide range of products such as liquid soaps, toothpaste, and even shampoo. However, once it is released into the environment, it can play exactly the same antimicrobial role. For instance, when it enters a sewage treatment plant, it can interfere with the microbes there that are there to degrade the waste. It can also have an effect on ecosystems such as the rivers and the ocean, where it will ultimately end up. Here at Cotron, we use fish to assess the effects of contaminants on the environment. The approach that we take is to measure specific responses in fish that are exposed to those contaminants. And we compare the responses to fish that come from cleaner environment.
Here at ESR, we're working with Cotron to look at the impacts of some of the chemicals, such as triclosan, on the environment. And in ESR, we're particularly interested in soil. So here we have a couple of soil types that we've collected from the field. And in this experiment, we're applying wastewater from houses, and this wastewater might contain chemicals such as triclosan, and we're interested to see what happens to the soil. So let's go and have a look in the lab. So here's some soil we've brought from outside, and we need a well-functioning, healthy soil to produce healthy crops. So soil contains a community of microbes that have really, really important jobs in soil function and soil health. And some chemicals can affect the way these microbes work. So here at ESR, we can look at some of these microbial processes in more detail. An example of one of these that we look at is the phosphatase enzyme.
Triclosan is only one chemical that we're using in the household. There are multiple other examples, such as metals that are found in antiperspirants and shampoos. There are fragrances that are used in shampoos and soaps. The impacts of those chemicals, once released into the environment, is unknown. However, it is recommended that we minimize their release.